Well, welcome everybody. Thanks so much, Lucinda. And so what we're going to do this evening is we're going to explore the idea of ancient sort of observations, basically. And there's just an amazing number of these things around the world. So what I'm going to do in order to do that, I'm going to share, I have a program set for this. It's one of those, I have to find it on my screen here. I don't think that's what I wanted to do. Hang on a second here. I think I have to, oh, well, if I'm sharing, hang on. I should be able to do this and this. Let's see. You can see my screen, is that correct? I'm just checking with my tech people here.
Yes.
Yes, okay, great. All right, then all I have to do is this. Okay. Just as a way of introduction, this particular part of astronomy, ancient sites, how people look at the sky, this probably really gave me the fascination to really explore astronomy in general. I am the planetarium director, although I've never actually had any formal classes in astronomy. But after more than 35 years of exploring the skies, I have a pretty good sense of it. And what I'm hoping to do this evening is to share with you some amazing things that have been around for hundreds, thousands of years. And I thought just to kind of set the mood for that, I've got a series of images and a little bit of music to play. We're hoping that the technical part of this should work out well. And so for the next few minutes, just simply enjoy the images and the music. And perhaps some of you might even recognize the music. So let me just get there we go. All right, so thinking about, the ancient observations, really, this is not so much thinking about the mechanics of how things work, although some of that will be involved, but really, this is thinking about what, in some ways, you can go outside and observe. And so here we are in this little blue dot that's out there, and our observations really have to do with what you go outside and see. And there's a key kind of place to start, I think, and it has to do with something that maybe we don't think about. But the moon that you easily observe in the skies just happens to be, and this is complete chance, this isn't true on any other planet, but here on the Earth, the moon is essentially the same size as the sun. It's just chance, but it is kind of interesting. But both of these objects, tracking the sun and tracking the moon, really involve telling time. And that's pretty much the theme that you will find throughout any of these civilizations all over the globe. Telling time, keeping track of time, is essentially why they observe the skies. And I mean, there are some very vivid examples, very noticeable examples. For example, something as simple as a month. Well, the word month actually comes from the word moon, the cycle of the moon. We'll talk a little bit more about that. But those kinds of observations really set a structure of time. And in order to have societies and civilizations, you need to be able to plan. And in order to plan, you've got to have time and calendars. And so that's really kind of the underlying theme to all of this. And so thinking about time.
Like sands through the hourglass, so are the days of our lives.
It's a goofy little idea, but anyway. Yes, keeping track of time. So, and there are lots of ways to do that. Something as simple as a sundial, and yet at the same time, people went through amazing efforts in order to tell time, not just say during the course of the day, but really over longer and longer periods of time. So the sun is key to all of that. So thinking about the sun, one of the things that you may or may not be aware of is how the sun changes in the sky. Now, there's some basic ideas that I think most of us have. The sun's higher in the sky and it's out longer during the summer. It is also out very briefly during the winter months. It also changes where it rises and sets along the horizon. This is something that, at least me personally, I never really noticed it, but I realized that where I grew up, I didn't see the horizon. We had trees on both the east and west side of my house. And so I didn't see the sun until it climbed much higher into the sky. And I quite honestly didn't pay that much attention. So, but where the sun rises and sets is really, it's very consistent. And over long periods of time, meaning months and seasons, you can tell time based on where the sun is. Now, of course, the sun technically doesn't move at all. We are doing the moving. And there are two parts to that. We're going around the sun, obviously, and the earth is also tilted. Now, one of the sometimes misconceptions that I hear about the earth and its tilt is that the earth leans toward the sun part of the year and away from the sun part of the year. Well, the problem with that phrasing is that the earth doesn't move back and forth like that. The North Pole, South Pole axis remains the same no matter where the Earth is in its orbit. So it's where we are that changes the angle that the sun is in the sky. One way to think about that in terms of observation, like I said, we can talk about some of the mechanics of it, but we want to do the observation because that's really what ancient people were doing. So this, by the way, is not in Vermont. It's in some places nice and flat. I believe this is Iowa. You can see the sun rising here. In this particular case, this is a summer solstice sunrise. So it's the first day of summer. The sun is rising. And I'll have you note the silos in that barn that's in front of us here. It just gives us a reference point in terms of where the sun is rising. At this point, the Earth in its orbit is angled so that the North Pole is leaning toward the sun. It gives us our longest days of the year, but it also places the sun very high in the sky, rising well up in the northeast, going not overhead. Even here, our sun doesn't go directly overhead. You have to head down toward the tropics for that to happen. But it does climb very high in the sky, and it doesn't set until it's way over in the northwest. So here we are on the equinox, and you can see the change in terms of where the sun is rising. It's now rising right between the two silos. Then we go to the winter solstice sunrise. Notice how much of a change there is. I think that's one of the things that I marveled at when I finally realized what was going on. There is a large difference in terms of where the sun rises and sets through the course of seasons. And again, this is the winter solstice sunrise. So the Earth, the angle of the North Pole is now angled away from the sun. The sun comes up lower, much lower in the sky, rising the southeast. It only is about to 23, 24 degrees above the southern horizon, even at midday, and then it sets in the southwest. So there is just kind of a profile. Like I said, you can see how much of a change takes place over 6 months. Now, it turns out the moon is a bit more complicated than that. In fact, I like to think of the moon as probably the most complicated and yet most common object in the sky. I mean, we all recognize it when it's out there, but some of the various changes that the moon makes, that's something that's, well, I think it's fascinating. So let's start with just some basics about the moon. So if we're viewing the moon, one of the things that I love, and this is something you can try out, it's a little more challenging in our climate because we live in a cloudier place than others. Places that have more consistent, clear evenings, this works out a little better, but you can piece this together over a period of months. But essentially, what I'm talking about is where you see the different shapes of the moon or phases of the moon at evening in the sun and just after sunset. So here we have a crescent moon. You will always see the crescent moon in the west. I didn't label west, sort of envisioning that you're looking south and that the moon being on the right-hand side of the image here, it's in the west. It appears just after sunset, and it isn't out very long before it sets as well. But you will always see a crescent moon in the evening in the direction of sunset. You'll never see a crescent moon in the evening in the east. So just something that you can kind of take note of. In fact, about 3 or 4 days later, you can see the moon is still a crescent, but it's much wider. It's also changed its position slightly, so that if we continue, we now see the moon due south just after sunset, and it's half illuminated. We don't call it a half moon, we actually call it a quarter moon, not because you can see 1/4 of the moon's surface, which technically is true, but you can see the moon a quarter of the way through its cycle. And I think that's kind of the key thing here. 1/4 of the way through its cycle, and so it's the first quarter moon. The moon continues on now that it has a rounded side, not completely round, but rounded. This is a gibbous moon. And then finally, we have the full moon. Now you notice it's on the opposite side of the sky from the crescent moon. The full moon always rises very close to sunset, and it rises in the east. And so that's a kind of a, if you were sitting on your front porch and it happened to face south, this is how you would see the moon change over a period of approximately, well, be really about 12 days. It's close to 2 weeks, but about 12 days from a crescent moon that you can see until the full moon. Now, just another little detail about that. So we've been talking about how the moon changes in terms of the sky, but if you could imagine yourself, and we are in this particular image, we are away from the Earth-Moon system. We're looking down on it. So you're looking toward the North Pole of the Earth, and you can see times. So 6 o'clock, 9 o'clock, midnight, and then into the early morning hours, and then the daytime hours. I mention that because the reason that we see the different phases of the moon, of course, is because the moon is different locations. So in other words, from our same location, looking at a waxing crescent moon, if you were imagining yourself near sunset, so let's just pick 6 o'clock as an average time. If you're looking toward the moon, you're looking at mostly the dark side of the moon. And that's why you see a crescent moon. As the moon progresses around the Earth, its first quarter moon actually looks just the way you would see it. As we get to the waxing gibbous moon, now again, you'll notice that these moons are all half illuminated. We're looking down, but what we would see from the Earth, you now see more of its sunlit side. So there's the gibbous moon and finally the full moon. Well, I shouldn't say finally. The other phases of the moon we didn't talk about. These are all phases that you see in the evening. But as the moon continues in its orbit, and I should mention the moon's orbit is 29 and a half days to go from one full moon to the next full moon. As the moon keeps going, we get to a waning gibbous moon. But if you're located up here in the evening and you're looking toward the gibbous moon, well, you can't see it. It's blocked by the Earth. And so you have to wait until later in the evening before the gibbous moon rises. In fact, that's been the case over the past few nights. Obviously, the cloud covers interfered with that. As the moon continues its orbit, we get to its third or last quarter. And finally, we get to a crescent moon. Now, I say finally because that's the last image that I have. I don't have an image of the new moon because you really can't see the new moon. The new moon is in the direction of the sun. The sun's on the outside of this picture, obviously, well to the right. But it's two things. One, you're seeing the dark or night side of the moon. There's nothing illuminated, therefore you wouldn't see it. In addition, it's out during the daytime, and that bright sky also precludes being able to see it. So there's our phases of the moon, but they are really important in terms of keeping track of time, and the ancient people watched this very carefully. One other note about the moon's orbit: it is slightly tilted. It is not perfectly straight. This plays into its role in terms of eclipses. If the moon were at the same level or same plane as the Earth's orbit, we would have eclipses once every month, but we don't. We obviously, they're much more rare than that. Now, the moon, as it turns out, follows approximately these same paths. So the same things that we discussed about the sun and its track across the sky, the moon does the same thing, except that because the moon's orbit is tilted slightly, it ends up that it can actually be a little bit lower than some of these tracks that the sun would take. So the moon can even be lower in the sky. Now, I guess I should be saying in specifically, we often think about the moon in its different phases. The moon through its different phases will actually follow these different tracks all in 1 month, but it changes in terms of time. As you saw, the moon's going around the Earth, so it changes when we can see it. So like I said, it is a pretty complicated object, but if you just thought about the full moon is opposite the sun. One of the things that you can take advantage of in terms of this image is if the moon is opposite, the full moon is opposite the sun, then in December, when the sun is tracking low across the sky, then the moon being opposite would track high across the sky. So the full moon in December follows the June 21st path, and that means that winter full moons are very high across the sky. In the summer, again, being the opposite, when the sun takes that track high across the sky, the moon, the full moon in the summer, is very low in the sky. Again, I don't know that you necessarily paid attention or noticed that, but this upcoming summer, definitely pay attention to that. Notice that the full moon in the summer is always quite low in the sky. So observing the moon is something that, like I said, the ancients were doing. It was a way of keeping track of time. These segments that we now call months, they've been somewhat divorced from the moon's cycle, and yet, essentially every month we have a full moon. Every once in a while, we have 2 full moons. I don't really ascribe to the idea of calling the second full moon in a month a blue moon, only because blue moons to me suggests that it's very rare. And 2 full moons in the same month happen about every 30 months, which, at least to me, is not all that rare. So keeping track of the moon in the sky, so we mentioned that it follows these different paths, and here's an example where the moon, kind of a time-lapse series. Here, this would be the moon in the winter sky. Again, it's very dark out for one, but as we get to the equinox, the moon basically follows the same path as the sun. And then in the summer, and this is really tough to see, but you can just barely make out these little dots over on the right. The full moon is very low in the sky during the summer. Again, following those paths of the sun. One other thing to note is the paths of stars across the sky. And this changes depending on where you're looking. In this particular image, we are looking north. And how would you know that? Well, you'll notice that these circles, and this is a time lapse, so each bar that you see, each line is the time, it looks like it's about an hour's worth of time that a star moved during that time. So it's a kind of a time exposure. But down toward the bottom of the picture, you'll notice things are kind of centered. Well, that's where the North Star is located. And as a result, everything spins around the North Star if you're looking in the northern part of the sky. If you look toward the east or west, we have rising and setting patterns that are on an angle. That angle is basically describing your angle in terms of where you are on the globe. The farther north you go, the flatter these lines are, the closer they are to the horizon. If you're at the equator, these lines are straight up and down. And finally, as we look south, at least from our viewpoint, again, you can see this arc of stars. You can see them curving, but you can't see the center of this arc. And that's because we can't see the stars that are in the southern hemisphere. And so those stars would do the same thing if you were in the southern hemisphere in parts of Africa, Australia, South America. You would see a pattern where there would be a rotation point, although no star there. There is no south star at the moment. Over long periods of time, thousands and thousands of years, there actually will be a south star. One other thing to make note of in terms of motions that people paid attention to, and that will be planets. Planets, unlike stars or the moon or the sun, took much more complicated and very individual sort of paths across the sky. This is just one example of the path of Venus. Even Venus doesn't take this same path, depending on where we are and where Venus is. It has, anywhere from 8 to as many as 12 different paths that you could see and observe during that period of time. Here's another example. This happens to be the planet Mars. Mars does something very unique. You can see this loop or circle. Mars actually does this. Mars appears in our sky, appears to go backwards for a period of time. We call it retrograde motion. In astrology terms, they talk about some planet in retrograde. It just means that it's moving backwards compared to its usual motion. It is an optical illusion, though, just to be clear. Planets don't change direction. They keep moving in the same direction. It has to do with the speed of the Earth relative to those planets. And so they occasionally appear to move backwards. So now that we have some background in terms of the things that you could observe, let's go to a place, and this is one of the very early areas in terms of observations. We go to northern Africa, and specifically the Nile River, ancient Egypt. Ancient Egypt, all kinds of observations in terms of astronomy, and fortunately, they had writing. This turns out to be a pretty big advantage. You'll see some examples of where that comes into play. It just simply tells us what they were thinking about when they were doing certain things. Now, not necessarily all the details, but the Great Pyramids are a wonderful example of how they were using even enormous, amazing structures like this in terms of astronomy. Obviously, the sun was one of the very key things in Egypt. Let's face it, they had about 350 days of sunlight there. And so observing the sun, that's a very critical part. And they did have, even going back thousands of years, they knew that not only was the year 365 days long, but they did have a leap year, so to say. They knew the year was actually 365 and a quarter days, and it was built into some of their observations. One of their observation sites is called the Temple at Karnak. This temple, a little bit south of where the Great Pyramids are located, and this is an image of how it would have looked when it was sort of complete. Today, this is what it looks like. Now, again, we're going back thousands of years, but this particular direction is keyed in on a star and its location and the time when you see it. So what happens is, it turns out that the star Sirius, which is the brightest star in the sky, sometimes known as the dog star, it is visible this time of year. It works its way across the southern skies just to the lower left of Orion. Sirius, as it turns out, rises just before sunrise in late July. Why is that important? Well, that is the time when the Nile River began its flooding. And the Egyptians needed to know that because that was critical in terms of raising their crops. The flooding of the Nile allowed all of those rich nutrients to spill into the floodplain, enriching the soil. And as the floodwaters receded, they did their planting, and obviously an amazing, successful civilization for hundreds and thousands of years. So there's a kind of an outer view of it. So when we're talking about these structures, they're not just casual, throw together type of thing. Amazing, tremendous effort put into creating any and all of these. So this is what we call the helical rising of Sirius. In other words, finding the star Sirius just coming up just before the sunlight is so bright that it overwhelms it. And that's what they were looking for. Another thing that they used, and we saw this image before talking about the North Star. In this image, the star right down here is the North Star. But they were able to use not specifically the North Star, but the pattern that you see. In other words, stars rising and setting. Why would that be important? Well, it turns out if you pick one star, it will rise. Actually, it would rise over here. It would rise the same distance away from the North Star to the right as it would set on the left. That means that if you could pick both of those points, the very middle is exactly north. And that's what they did. In terms of, and specifically, the Great Pyramid. The Great Pyramid is an amazing structure. We could probably do an entire program just on that. But it is set so that it is almost precisely north, south, east, and west. It is off by what we call an arc minute, a tiny, tiny fraction of a degree. It is basically lined up perfectly north, south, east, and west. It is also, just in terms of the amazing part of the building, it is more square. In other words, its structure is more square than any modern building in New York City. Kind of pretty amazing. One of the things that we know that's in the Great Pyramid are what we call air shafts. Now, yes, are they air shafts? Well, the ancient pharaohs that were supposedly buried in there, by the way, no body was ever discovered within the Great Pyramid. But these air shafts point to very specific locations in the sky. And so they highlight Orion, the great constellation that we can see, but for the Egyptians, he represented the resurrection and the afterlife, where pharaohs were heading to after they left the earth. Sirius, the star, the brightest star in the sky that we just talked about. And then on the other side of the pyramid, we have air shafts that point to the North Pole star, which you may notice isn't, I don't know how familiar you are with constellations, but I'll just briefly point out that this air shaft is not lined up with the North Star that we know today. It's lined up with a star named Thuban, which is in a constellation Draco the Dragon. That's where the North Star was located during the time of the Egyptians. Now, this still works, but the sky would have changed so that the North Star that we now talk about is actually lined up with this air shaft. One other just quick note here, and it's mostly a mystery, but well south of all of this and older than the pyramids, there are these standing stones. Well, some of them have leaned over thousands of years, but this was erected by a people that we don't even know about. Nevertheless, they were, and it appears from various alignments that astronomers have checked, that these were an ancient type of calendar. They were observing the rising and setting points of at least the sun and likely the moon as well. We now move to the British Isles, and the British Isles are just absolutely full of examples of these ancient observing sites. We have many examples of these standing stones, menhirs, another term for them, and they're scattered all about the British Isles. They're actually also found in northwestern France as well. They mark various rising and setting points, generally of the sun or the moon. We also find these ring structures. They're actually a bit more common in Ireland because, as it turns out, the Irish are very superstitious and they didn't dare change these things, afraid that they would upset the fairy folk and so forth. And so as a result, there actually are a number of sites that haven't been greatly disturbed in Ireland. Now, these stone structures sometimes have been claimed to be ancient tombs and so forth. And while there certainly could have been some bodies built in them, there's a very, very strong connection to astronomy. So in the case of some of these standing stones, they mark a certain rising or setting of the sun at a particular time. It might be, see, the winter solstice sunrise or sunset, or the summer solstice. And so if you think back to those images that we saw with the sun rising during the different times of the year, these standing stones would mark certain points during the year. Here's one in Scotland, and you can see that in this particular case, they used one stone, but the names that you see in the background here mark the most northerly, max, and the most southerly, min, rising points of the moon through its 18.5-year cycle. So this is something that was set up, and over long periods of time, people were observing this carefully over extended periods of time. Now we go out into the plains in, this is in Surrey in England, something known as a chambered cairn. It's also, well, let's actually just kind of show you this illustration. What this is a mound, a man-made mound, and it has a chamber that goes into it. And the chamber is aligned with, again, either a sunrise or a sunset at a particular time of the year. The sunlight comes through basically just when it's lined up, and so you can use these as a calendar device. It might be the winter solstice sunrise or sunset. It could be the summer solstice sunrise or sunset. This is one example, the winter solstice sunrise. This is in the Orkney Islands in far northern Scotland. This is called Maze Howe, just an amazing building where the light travels through on the first day of winter. So we'll go to Ireland. There's an amazing example of this in Ireland, a place called Newgrange. Now, unlike modern practices, in the middle part of the 20th century, it was common to restore such things, and that's exactly what they did. So this has been restored. Fortunately, this restoration actually kept intact the key part of this, that chamber that I just described. Now, this huge mound It covers over an acre of land. The white rocks that you can see there are quartz that were specifically brought in from a different location. I don't recall the location right now. But again, this one was very carefully lined up so that on the winter solstice sunrise, the sun traveled about 66 feet into the very back of the chamber through something called a roof box. So this is the outside view of the roof box. So there's the doorway, but above it, you can see this other location. And it's because of the angle. They were really trying to get it as precise as possible. And so this is a view from the inside looking out. They still permit people to go inside. I assume not now with the COVID situation, but I was there about 5 years ago, and I was able to stand right in the middle of that mound. It's just kind of an awesome thing to think that you were standing in some place that's older than the pyramids, and their roof structure is such that they have not had a roof leak in over 5,000 years. I wish my roof was so well designed. And then here's the sunlight hitting a few actually drawings that are on the very, very back of the cave. Here's a lesser known one, so not very far from Newgrange. It's known as Knouth. And Knouth and another one, Douth, set up in a very similar way, just in a much smaller, less grandiose fashion. But these, again, were lined up with these various points of the sunrise. In this particular case, the stones were leaning. And so you can see how that would make it very specific in terms of when the sun would travel all the way through. Probably the most famous, ancient observing site is Stonehenge, no question about it. Stonehenge does mark sunrises and sunsets, moonrises and moonsets, and might even do some other things as well. This is a case, and this is true in Ireland as well. So we mentioned that the Egyptians had writing. The people that built Stonehenge, the people that built Newgrange, had no system of writing. We can make a lot of guesses as to what they were, attempting to do and how they were attempting to do it, but we really don't have any written record of it. Now, we do know that the alignments of Stonehenge are such that they could do a tremendous amount of observing. Now, Stonehenge, as it exists, is actually the end stage of something that was taking place at various stages of it over thousands of years. The very earliest stage of it was simply a ring or henge, as it's known, where dirt was excavated and piled up into mounds on the inside and outside. And then there are these series of holes. There's actually 56 of them. They're known as the Aubrey holes after Sir Aubrey that discovered them. They appear to relate to the cycle of moons. That would be 56 would be basically 2 moon cycles. Over time, they discovered other holes that would be kind of out in this particular direction, and they were likely doing some work trying to figure out the alignments for various sunrises. And so eventually they started using stones, and these stones were then rearranged to eventually come to what we see now. Again, it's since then the stones have been fallen down. Some of them have actually been removed from the site, not anymore. But this was perfectly aligned with the summer solstice sunrise. And so, again, they were observing the same kind of idea that you can observe in terms of where the sun was rising or setting. And they also observed the moon. And in fact, this image shows a number of holes here. This is a fairly even group of holes out here, but right where the entryway is, a series of holes. We think that they were trying to very specifically measure the motion of the moon. Like I said, the moon's orbit is tipped, but if you could measure it enough, it's possible. It's not necessarily likely, but it's possible that they could have predicted eclipses, especially lunar eclipses. Solar eclipses would have been far more difficult. In fact, this whole idea of eclipses is a bit challenging just to even sort of think about, but we'll kind of quickly review it here, is that the moon in its orbit around the Earth, obviously the moon we know is the new moon, would be between the Earth and the sun. and the full moon would be on the other side of the Earth from the sun. It is, however, tilted on an angle. And again, as I mentioned, therefore we don't get eclipses every single month. In fact, here's these little blue squares are the angle that the moon is orbiting the Earth. And as it does so, if it's perfectly lined up, we do get a solar eclipse. Now, just as an example of how rare solar eclipses are, here in the North Country, our last visible solar eclipse was in 1932. The good news is you don't have to wait that long. The next solar eclipse visible here will be April 8th, 2024. So just a little more than 3 years from now. In less than 3 years, the museum will be doing lots of programming. COVID will be behind us. We will have some amazing programs for you. Then we have lunar eclipses. They are a little less rare. You can usually see one about every 3 years. Of course, the timing is such that a lot of times they might be at 2 o'clock in the morning. So the fact that you can see them doesn't necessarily mean that you will see them. And of course, our cloudy skies don't help at times. But there is one of the more unusual things about a lunar eclipse is the moon actually turns this reddish color. Now, sometimes it can be a bright coppery red. Other times it could be more of a dark kind of a brick red. The reason that the moon has any coloration is that if you think about it, okay, the moon is now in the Earth's shadow. So if you look back toward the Earth, it's covered by the sun, but all around the Earth, there are sunset colors. And it's those sunset colors that give the moon its coloration. Now, obviously, some sunsets are bright, some are dull. And the amount of volcanic ash, it turns out, in the atmosphere is also a factor. More volcanic ash, it actually subdues how much light reaches the moon. Our last basic stop here, we're going to southern Mexico and also parts of Guatemala and Honduras, the area that was at one time the heart of the Mayan civilization. Now, the Mayan civilization in some ways was just kind of lost in the jungle. There are still many, many sites that have not been completely excavated. But those that have tell some amazing stories of a civilization that knew all kinds of things about astronomy that, well, it kind of boggles the mind. For one, just as an example, they were observing the planet Venus. Venus and its motions were so well documented by the Mayans that until the advent of computers, their predictions of Venus's location were more accurate than any of our science, like I said, until the age of computers. Now, this particular image, this is sometimes known as the Castillo. This is a pyramid, a stepped pyramid. And the fascinating thing about this particular pyramid is how it's lined up. The steps, of course, mean that if the sun is on just the right angle, it would create a shadow on this long set of stairs. Again, this is a fascinating building. Just briefly, there are 91 steps. Why is that important? Well, there are 4 sets of 91 steps. That's 364 days. There is one more step. That's to get into this top part. That's 365. Just kind of amazing that they set it up that way. This is what it looked like before they did some other restoration work. And it isn't completely restored. With the side that you saw is what has been restored. This is a closer look at the staircase. And you can see the wall that's there. And then at the very bottom, there's this some kind of feature here. Let's see if we can get a little better look at it. There it is. It is basically the serpent head. Now, keep that in mind. So this is the head of a serpent. And when on the equinox, either the spring or fall equinox, the sun creates this zigzag shadow coming all the way down to the base where the head appears. This looks like a serpent. So they designed this building and lined it up perfectly so that on the equinox, you would see a serpent coming down the steps. Another amazing building is the Carrack Hall. The Carrack Hall this is in Chichen Itza. The caracol is also called the observatory. And it does kind of suggest that it's a round building. Obviously, it's deteriorated on the top. Did it have a dome? No, it never had a dome. It wasn't an observatory with a telescope in it. It was, however, an observatory. The windows that you see, and even those that are somewhat collapsed, they have been able to determine the alignment of those windows with various things in the sky, specifically Venus. They were observing Venus very carefully. And so if you look in this diagram, they actually have this line here, and it shows the northern Venus setting point. There are other windows that are lined up so that they could see the summer solstice sunrise or the winter solstice sunset. So this is, again, a very carefully laid out building, and they were paying, in particular, a lot of attention to the positions of Venus, the southernmost position of Venus or the northernmost position of Venus. And fortunately, we do have some of the writing. Unfortunately, 90, perhaps 95% of their books were burned. The Spanish conquistadors, seeing this, they did not want the native people to have their language and so forth, and so they burned their books. A very tragic sort of story as far as that's concerned. But fortunately, there was a Franciscan monk who realized the value of the books and actually hid 4 of them away, and enough so that we were able to decipher the various, what they call glyphs, their system of writing. But also, this had a lot of information about astronomy, including some of their predictions of the positions of Venus. In fact, this particular building, this is in Uxmal. This is the governor's palace. It's kind of in the center of the picture here. And this has a very specific alignment in terms of astronomy. So we have a 2-headed jaguar that was a theme in the Mayan civilization, but it noticed that it has a dip in it. Also notice the stone that has fallen over. If you get that stone so that it is upright once again and stand in the center window and then look over the stone, over this dip in the double-headed jaguar, you are looking to the rising point of Venus. Now, it's not terribly well seen in here. There are a couple of very tiny dots in here. You may have to kind of get right up next to your computer to see it, but there's Venus and another planet. I expect that would be Jupiter, but they would be rising. So this is, again, just a testament to how much observation that they did so that they could create these amazing buildings and other structures to be able to measure such things. Now, these are just, I picked out 3 civilizations that we have a fair amount of knowledge about, but there are examples of this all over the globe. So this is a medicine wheel, as it's known. This is in Wyoming. The various lines of stones that you see here all equate to various locations to look for rising and setting points of different stars, and they've been able to document some of that. This is one of the more fascinating places. This is in India. Now, first, it looks like a bunch of staircases, but look at them carefully. They have different angles to them. Some of them are very steep, others are very shallow, and they are pointing in different directions. Each one is aligned to a specific star on a specific date. This is not necessarily very ancient. I believe date-wise, it was built about 1,000, maybe 1,500 years ago. I don't have a lot of knowledge about this particular location, but it is just another example of how much effort people put into measuring the skies. One other fascinating thing, and I don't know if you have any labyrinths near you, but the idea of a labyrinth, of course, there is the Greek myth of the Minotaur and the labyrinth, but that is not necessarily a good example of that. And here's why. It turns out a labyrinth is not a maze. A maze suggests that you would have to try to figure out some particular path to find your way through. A labyrinth is one path. Now, if you can sort of imagine, and you can sort of see a little bit in this diagram, that basically when you go into the labyrinth, you start looping back and forth and back and forth. A curious thing, and I did some work with Sig Lonergan, who used to live in Greensboro. He's now located in Britain. But Sig and I worked out and realized that these patterns very likely mimicked the path of Mercury in the sky. Now, the back and forth actually was something that took place underneath the Earth, because Mercury only appears just briefly, either in the morning or the evening, but it dips underneath the sky and then comes up on the other side over a period of several weeks to several months. And so we think, Sig and I, that they really were related to observing Mercury. So another fascinating thing. And finally, we go to Vermont. And so this is in Woodstock. They are known as Woodstock 1, Woodstock 2. They were very often described as cellar holes or root cellars. But these root cellars were built before any European settlers got here. And even the Native Americans that they spoke to, they didn't know where they came from either. These are very old. We don't know how old. We do know, though, that they are, again, aligned so that on the winter solstice sunrise, the sun goes in through this. Now, it is not as precisely lined up as those that we talked about in Ireland or England. Nevertheless, it is highly unlikely that these openings would have been set up in such a way that they just happen to be facing in that direction. And in fact, one possibility is that although the sun is located and coming in here, there may have been another object in the direction of the sun that helped to be more precise about this alignment. So that is my program for this evening. Kind of a look at what you can go outside and see, in terms of observing the sun and the moon, and then some of these amazing things that are found all over the globe. So having finished that, I'll now kind of, I guess we'll open up things for questions, if anybody has any.
Well, we're waiting to see if any questions come into the chat. I have one. Why Venus?
Why Venus? Well, it's very bright. And as I mentioned, it has many unique patterns, so not just a single pattern. And by observing it, one of the things that the Mayans realized is that there is an 8-year cycle of Venus. This is something actually we observed it was really cool. In 2012, Venus went right through a pattern of stars known as the Seven Sisters or the Pleiades. This repeated again in the year 2020. And so if you want to plan it, put it on your calendar, it will happen again in 2028.
We have some more questions coming in now, several around Woodstock. Where are the Woodstock, quote, root cellars?
I do not know their location. I've never been to them myself. So, and I know they're at least somewhat protective of where they are. We don't want, obviously, large numbers of people would be kind of a problem. I would check with somebody in the Woodstock Springfield area.
Another question we have here is whether such structures have been found in Russia or Mongolia and Northern Asia.
I don't know of any in Russia or Mongolia. And the other place, Northern Egypt, you said?
Russia and Mongolia, just Northern Asia.
Oh, Northern Asia. I'm not aware of any, but that doesn't mean that they're not there. A lot of these structures, well, even like the Mayan, for example, they were lost in the jungle. We didn't even know about them until relatively recent times.
Well, and speaking of Mayan world, someone wonders if you could they couldn't hear the names of some of those temples and wondered if you could re-mention them again or where they are.
So the major ones, there was a large pyramid structure, a stepped pyramid, we call that, and that's known as the Castillo. And then there was, toward the end, we talked about the alignment of Venus. That was called the Governor's Palace at Uxmal. And then finally, in between that, there was what we call the observatory or the Caracol, and that is in Chichen Itza.
Here's one more coming in. Are there any connections with the stars, planets seen in the Native Americans of the Southwest in that culture?
Yes, there's a wonderful example of it. I'm going to blank on its name just off the top of my head. I can see it, and it has a letter C in it. But it is a location where slabs of stone were set up so that a narrow wedge of sunlight reached a spiral diagram, but it only happened on, I believe it's the summer solstice sunrise. And so that's just an example of one that just comes to mind immediately. Again, I apologize, the name escapes me, but just an amazing, just an example of that.
Mm-hmm. Ooh, now we're getting technical. How does the Milky Way move in the sky?
The Milky Way, well, and it's kind of interesting, and I've always tried to figure out a way to better describe this even to myself. The Earth's orbit around the sun, and that really is kind of what affects what we see in the sky, is not lined up with the Milky Way. So what it ends up happening is, I guess the best way to describe it is, the Milky Way is very close to the horizon during May and June, and then it slowly lifts up into the sky during the latter part of summer into the fall, but then it makes a twisting motion. And so it gradually pivots around so that it stays above us for the most part through the winter. And then in April, it starts lowering so that we're back to May and it sits along the horizon. So the best time of the year to see the Milky Way is from late summer all the way through the winter. And the least favorable time is during May and June.
Well, I think I can echo this. Jay says, many thanks. It's so great to see your voice for once. And I think we all might agree with that it's really fun to see you after we hear you so much on Eye in the Sky. So thank you for coming tonight.
Oh, I just love doing these programs, and great that everybody could participate. So.
Well, thank you. You
Thank
have a
you,
wonderful
everybody.
voice. I love your voice.
Thank you.
Thank you, everybody, for coming tonight and joining us on First Wednesday. And we'll see you in a month.
Terrific. Thanks.
Well,
Thank you.
Thank you very much.
Thanks. Thank you, everybody. Thank you, Mark. That was wonderful. Thanks so much.
You're welcome. Yeah.
Yes, Mark. Someone said you're giving me the urge to travel again. So I don't know if we should be thanking you or not.
Oh, soon enough.
Soon enough.
You can do your planning now.
Exactly. Right? Add all these to our lists.
That's right. Right. I will say that's one thing about being stuck at home in this world is that, you spend so much more time, you have more time to look around and to look at the sky and to look at how the stars move. And I used to get, my newspaper used to be delivered very early in the morning. And there was a time in October when there was you talked about it one time on the radio, these two stars got closer and closer. And I would be out there around 5:30 in the morning. I could see it. And I was like, I understand this now. And it's just, it's great to have that ability to be able to be observant. Well, I be in Vermont, so we can see the sky.
Right. Well, astronomy really is I guess, kind of a somewhat more subtle thing in terms of, and it's one of the reasons that I love starting my program with that long piece of music and those images. It's much more contemplative. It's not, sort of the bang zoom kind of thing that a lot of, it seems, the younger generation appreciates, although I know a lot of young people that really, really love astronomy. So
I used to wonder why it seemed to be that ancient peoples spent so much energy in their observing the stars and planets and so forth. And it finally occurred to me that given that most of us only need 6 or 7 hours of sleep, people had a huge amount of time that was dark. And back when light was a valuable resource. I mean, you couldn't just burn candles all the time. That was people just didn't have light. And so it occurred to me, the three things that people did a lot of was look at the skies, because you could just sit out there and look at the skies. And the other was to tell stories, to do oral things where, like in the Bhagavad Gita, I mean, it was all oral traditions as well as Native Americans. And of course, the third thing it could do is make more babies.
Yeah, I do think that, you mentioned the storytelling. We know that the Celtic people had no system of writing until much later in their time period. And without that writing, that's how they relayed that information from generation to generation, was by telling stories.
Mhm.
It's interesting because they really, I mean, it was a perfect setup. I mean, because they just did have that time. Most of their work, they couldn't work, they couldn't hunt, they couldn't, really do much at all when it was dark. So it all kind of makes sense that these oral traditions, as well as the attention to the heavens.
Mm-hmm.
When you look at, I'll bring it back to Norton Historical Society, but when you look at, diaries and letters and journals at NHS, you see over and over again how important light was, how important the moon was, how much it impacted people's travel, their visiting, their social, their garden, their, growing of food.
Yeah.
But it was just everything. And knowing that moon, especially knowing the moon, was incredibly important. It's constantly mentioned in diaries.
Mm-hmm.
Full moon tonight, we went to so-and-so's house.
Sure.
Because they could
Yeah.
see to get around.
Yeah.
Mm.
And that's why the harvest moon's so important.
Yeah.
I mean, it was one of those things where you had to get the harvest in. You don't have, the luxury of putting it off. And so by having light out even through the nighttime hours, it gave them many more hours to be able to get that harvest in.
Yeah.
The moon is so bright in the winter. It took me a long time to figure out that it's always brighter in the winter because it's so much higher.
Right.
But I can imagine, people on with sleds going visiting, they could visit at night, and they could because they, aside from the horses knowing the way home, they could probably see a lot when a moon was out.
Oh yeah. Well, I love a moonlit snowshoe or cross country ski. I love to be out in the moonlight.
Great.
All right. Well,
Thank you.
I think we should say good night, and thank you so much, everybody, for a great evening.